Dear students, welcome to the video differentiation equation of tangents and normal to the curve. In this part of the chapter, we are going to learn how to use differentiation in order to find equation of tangents and normal to the curve at a given point. Now consider this point P with coordinates x1 and y1. Now, we know that tangent is a straight line which just touches the curve at the given point, and it has just one point of contact with the curve. As you see, the diagram clearly shows that this tangent just touches the curve at point P. And normal is a straight line. You have learned in coordinate geometry, normal is perpendicular, but for the curve, normal is a straight line which is perpendicular to the tangent at the given point. Now, as you see, this tangent and normal at the point of contact make together angle of 90. Now, we have learned that gradient formula of the tangent to the curve is obtained by dy dx. So step one. First, we find an expression for dy dx which gives you gradient formula. Step 2, just we substitute x1 in dy dx to find m, which is gradient of the tangent to the curve. Now step 3, I write step 3 here. Step 3 now is to write equation of the tangent. We learned equation of the line, a straight line, is y minus y1, which is y coordinate of the contact point, is equal to m x minus x1. So it is equation of the tangent to the curve at P. You already know this formula in coordinate geometry. You have learned how to write equation of straight lines, but the only new thing here is how to find m. M is found by differentiating and substituting the x coordinate of the point. Now, in order to find normal, we know that these normal and tangent are perpendicular to each other. So if I use m prime as the gradient of the normal, m prime will be negative 1 over m, or we know that m prime is equal to negative 1, because we know that when two lines are perpendicular to each other, the gradient is negative reciprocal, or you could say the product of their gradients is negative 1. So in order to write equation of the normal, we use again the same point, but as gradient, because it is normal and is to be perpendicular, we use negative reciprocal of the gradient of tangent, so x minus x1. So this is equation of the tangent, and it is equation of the normal to the curve at P. Now let's see some more examples. Example number 1, find the equation of the tangent and normal to the curve y is equal to 2x squared plus 8 over x squared minus 9 at points where x is equal to 2. Now we know that in order to write equation of the line, because tangent and normal are both straight lines, we need to have gradient at one point. So to find the gradient, we need to have differentiate this expression to find gradient formula. First, we know that to write equation of the line, apart from x coordinate, we need y coordinate. I first find y coordinate. So y will be 2, 8 over 2 squared minus 9, which will be 2. It would be 8 plus 2 minus 9, which will be 1. So our point is 2 and 1 as x1 and y1. To find the gradient, we need to first differentiate this expression 2x squared. I changed the form to make it possible and easier to differentiate. So y prime will be equal to 4x minus 16x to the power of negative 3. Differentiation of 9 is 0. So y prime will be equal to 4x minus 16 over x cubed. It is gradient formula, but we need gradient at the point for which x is equal to 2. So I replace 2. Then it will give you gradient at the given point. 4 times 2 minus 16 over 2 cubed. So it will be 8 minus 16 over 8, 2, which is 6. Now m is 6, and we know that from coordinate geometry and what you saw in the previous part, the gradient of the perpendicular is denoted by m prime is negative reciprocal, so it will be negative 1 over 6. So we have gradient of both tangent and the normal to the curve. Now to write equation of the tangent first. Y minus y1, which is 1, is equal to m, gradient was 6, x minus 2, so y will be 6x minus 12, negative 1 is transferred to the other side, so y will be 6x minus 11. It is equation of the tangent. For normal now, we use the same formula, but gradient of normal must be implemented. Y minus at the same point, y1 is equal to negative 1 over 6, x minus 2. Now, in order to get rid of this fraction, I multiply all by 6. It will be 6y minus 6 is equal to negative x, then negative times negative, it will be positive 2 then. So it will be 6y plus x is equal to 8. So it is equation of the normal. Example 2. A curve has equation y is equal to 4 minus root x to the power of 3. The normal at the point P, 4 and 8, and the normal at the point Q with coordinates 9 and 1 intersect at point R. Find the coordinate of R. Part B, find the area of triangle PQR. First, it is talking about the normal. In order to find equation of the normal, we need to have first gradient of the tangent, which is obtained by differentiating the original expression. So y is equal to, instead of radical x, I write x to the power of half to the power of 3. Now here chain rule must be implemented. So y prime is equal to, if you remember, power is multiplied, then differentiation of u. It is your expression which is called u. Differentiation of brackets, differentiation of 4 is 0. Then differentiation of x to the power of negative, x to the power of half will be negative half x to the power of negative 1 over 2. Then u to the power of n minus 1. X half to the power of 2, or it can be written as 3 negative 3 over 2. It goes to denominator, so it will become to the power of positive 1 over 2, which is radical x. Then 4 minus root x to the power of 2. So I rewrite, it will be negative 3, 4 minus root x to the power of 2 over 2 root x. It is the gradient formula. Now let's find m. M at point first P, x is 4, then m will be equal to, it is minus 3, 4 minus root 4 to the power of 2 over 2 root 4. It will give you negative 3 as the answer, and if x is 9, m will be equal to, at point Q, negative 3, 4 minus root 9 to the power of 2, 2 root 9, which will give you negative 1 over 2. Now we should write equation of the normal. These are m actually. Then m prime will be negative reciprocal. So it is negative becomes positive. So it will be 1/3. And here m prime will be positive 2 for these two distinct points. So at point P, normal will be y minus 8, which is y coordinate, and gradient of the normal is 1/3, x minus 4, and for the next one, y minus 1, y coordinate is equal to 2, x minus x coordinate, which is 1 here. I first multiply all by 3, it will be 3y minus 24 is equal to x minus 4, and here it will be y is equal to 2x minus 2, negative 1 is transferred to the other side, it will be minus 1. Then you have a pair of simultaneous equation. It will be 3y minus x is equal to 20, and for the second one, y is equal to 2x minus 1. Now here you can easily use substitution method. Replace 2x minus 1 in the first equation, and after you solve, it will give you 14.2 as x coordinate, and y coordinate will be 11.4. So these are coordinates of point R, 14.2 and 11.4. In the second part, part B, you are asked to find the area of triangle P. It is QR. As we don't have angle, you cannot use actually the formula which is using trigonometry to find the area, and it's not right angle triangle to use base times height. So as you see here, we have coordinates of P, Q, and R. I make a rectangle as you see in the diagram. So you will have one rectangle and three, do you see three small triangles? If you subtract the area of these three, because they are right angle triangles, three small triangles from the rectangle, it will give you the area of the shaded region, which is area of PQR. So first I find area of triangle, area of rectangle, will be equal to length, which is 10.2 times 10.4. Then area of the shaded region will be equal to actually 10.2 times 10.4, which is area of rectangle minus these three small triangles. For the first triangle, it has a height of 7, base of 5, so it will be 5 times 7 divided by 2, plus the second triangle is 10.2 times 3.4 over 2, half of base times height, plus, and this one will be 10.4 times 5.2 over 2. And at the end, you will have 44.2 unit square as the area of area of triangle PQR.